Okay. Now we shall see what is shift register. Okay. You should not mistake this particular register for resistors. Yeah, you should not mistake the register for this. It is register, which means it's a storage element, not resistor. Fine. Now here, so register is nothing but a bistable or a flip-flop. It is a storage element. It stores 1-bit data. Okay, the 1-bit data that it shows is either a 0 or 1. Then the shift register is this. What is shift register then? Shift register is two or more bistables connected back to back. Connected back to back means connected in series. Understand that? We say it is connected in series. Fine. And it not only stores 1-bit data, but also shifts the data to right or left. Not only stores 1-bit data, but also shifts the data to right or left. So that is what is a shift register. A register is one flip-flop. Register is one flip-flop. Let me just correct this. Okay, let's not say bistables, but it is one bistable. Any one bistable. It's one bistable. It stores 1-bit data. Shift register is two or more bistables connected back to back, connected in series, or it can also be called as series or cascade. It is also called as cascade connection, connected in series or cascade. Cascade is series. I'll show you what it means. Fine. So this is the introduction to shift register. Register stores, whereas shift register does not store, but along with that, along with storing, it also shifts. Does not only store. Along with storing, it also shifts the data to right or left. So that's a shift register. Okay, and let's see the types of shift register. Everybody, okay, see here, types of shift registers. Okay, so one is serial in, serial out. So it is called as SISO. Fine. Second one is parallel in, parallel out. So it is called as PIPO. Okay. So similarly, can you make out what is this? SIPO and PISO. Can you make out what is third and fourth there?
Serial in and parallel out, parallel in and serial out.
That's it. Okay. So there are 4 such shift registers wherein the data can be serially sent in and serially taken out from that, or parallelly all the data can be given at a time, all the bits, and all the bits can be taken out at a time. So that's parallel in, parallel out. So this is SIPO is serial in, parallel out. We give the input serially and take them out parallelly. Whereas here we give the inputs parallelly and take the outputs serially. Okay, so there are different types. In this, we shall see a 4-bit SISO shift register. Now, everybody take the heading as 4-bit 4-bit SISO, serial in, serial out, shift register. Very interesting stuff. You just have to understand this very well. And for understanding this, okay, we need to have the good knowledge about the bytes tables. Fine. Now for this, we use JK bytes table. Okay, and since it is 4-bit, we use 4 JK bytes tables. 4 JK bytes tables. Okay, and this JK bytes tables, all the 4 JK bytes tables have PR, CLR, J, K, clock, Q, and Q bar. All this would be there with each JK bytes table. So we have 4 JK bytes tables. In each JK bytes table, what is this PR? Anybody?
Preset.
Preset. CLR is clear. Okay. When preset and CLR are 1, then clock gets activated. So when clock gets activated, it will look for JK. If JK is 00, Q is not changed. If JK is 01, Q is 0. If JK is 10, Q is 1. If JK is 11, Q toggles. Fine. So that is what we have to have as a prerequisite to understand the functionality of this. Now we shall write the 4 JK flip-flops. Okay, then I'll explain you this. So you need to be really good with this. So let me just do it with these blocks which are there. Let's have this as one block. Then let's just copy this. Where did I put that? Oh, fine. This is the second one. Third one. Fourth one. So we have 4 JK flip-flops like this. Fine. Now all the JK flip-flops will have the input pins and output pins. So let's say this is J3, K3, J2, K2, J1, K1, J0, K0. Like this, we have JK inputs. So along with JK inputs, we need to have clock, and all the 4 JK flip-flops are having clocks like this. Everybody see here? Clock with a bubble. Mind you, it's a clock with a bubble they have given. Is it fine? So if you give bubble, it is rising edge of the clock that it works for. Fine. If you don't give that bubble, okay, it works for positive cycle of the clock. Fine. Now let's see this. I'll just show you this. This is the clock that is there. Okay, and This is common clock for all the flip-flops. Common clock. So I'll draw a line, okay, and I'll supply clock like this. See, all are taking the same clock. So this is clock. Fine. Then we shall have a clear pin. We shall have a clear pin like this. So this is a clear pin, CLR. Fine. Then here, this first, let's have Q3 and Q3 bar. Here Q2 and Q2 bar. Q1, Q1 bar. Q0, Q0 bar. So this is how the things are. Now, the output of first flip-flop is given to this, and this Q3 bar is given to K2. So that is what you need to do with every flip-flop. The outputs are connected to the inputs. The outputs are connected to the inputs. Fine. Unless there is a bubble, there is no connection. So here is a connection, here is a connection. All in these places you have connection. Similarly, here you have connections. Okay, but here you don't have. Here you don't have connection, mind you. Where I don't put this button, okay, there is no what connection. Fine. Now there is interesting thing happening. Everybody just see here. The first input, okay, J3, and from there I take a NOT gate and give that to K3, and the serial input is 1010. So this is in this direction, it is called as serial input. Okay, and here you get serial output. Understand? And along with clear, we need to have a preset also. Okay, so let's do that preset here. Let's do the preset, the common preset to all the flip-flop, mind you. So this is the preset pin, PR. So we have preset, all the presets of all the flip-flops are connected to common preset. All the clear of all the flip-flops are common connected to common clear, and the clock is also common to all the flip-flops. This is how the connection is. Okay, and you have this serial input. So now everybody understand this. We shall see how this particular block diagram or circuit diagram works. So we are talking about serial in, serial out. That means this 0 at first clock cycle should come to Q3. At second clock cycle should come to 0, come to Q2. So when this 0 comes to Q2, this 1 should come at Q3. So that is what we are doing. Understand that? So let's analyze this particular thing. Now what I want you to understand here is, okay, to begin with, okay, what I do is this. PR is, let's say 1, and CLR is 0. PR is 1 and CLR is 0. What should happen to the output of these flip-flops? Can you tell me? Can you tell me what
0.
happened? what should happen to all the outputs? Because it's the common preset to all the flip-flops and common clear to all the flip-flops. So clear is 0, preset is 1. So that means it is not getting preset, but it is getting clear because there is a bubble. So it's a negative logic. So all the outputs are cleared. All implies all the outputs are cleared. All the outputs are cleared means, what does that mean? That is which are the outputs? Q3, Q2, Q1, Q0 all have become 0, 0, 0, 0 to begin with. So before we begin, if there is any data, we want all that data to be cleared, and for that I make clear equal to 0 and preset equal to 1, so that I'll have this output in all the flip-flops. All the flip-flop outputs are 0, 0. When I say flip-flop output, I mean Q3, Q2, Q1, Q0. I'll not be bothered about Q3 bar, Q2 bar, Q1 bar, and Q0 bar. Okay, we know that is not of Q3, not of Q2 and all that. So till here it is fine. So I have cleared to begin with. Now, when would clock get activated? Anybody? When would clock get activated? So this is step 1. This is step 1. When would clock get activated? Can you see?
When PR and CLR is 1.
When PR and CLR
PR
are
and
1.
CLR.
Very good. Step 2. In step 2, okay, we make CLR equal to 1 and PR equal to 1. Okay, this implies that, okay, clock gets activated. Clock gets activated. Till now, till this is not 1, 1. Okay, clock has got no importance because all the importance would be there with PR and CLR as long as clock is not activated. When would clock gets activated? When CLR and PR are 1, 1, clock gets activated. Fine. Now, when clock gets activated, let's see here now. Okay. Now, clock serial in data, the outputs Q3, Q2, Q1, Q0. Okay, this is how it looks like. So to begin with, what is that? So it's serial in is 1010. Understand? Now there is 0. Let's write this clear zeros little smaller. 0, 0, 0, 0. So this is how the things are to begin with. Now, when there is first negative clock cycle, everybody understand this. When there is first negative clock cycle, why we are talking about negative clock cycle? Because we have 0 here. We have a bubble here. That's why we talk about negative clock. So if you remove this bubble, this clock would be positive clock. That's it. In the textbook, what he has done is, though he has put bubbles, he's taking positive clocks here, which is wrong. Everybody understand? So we should take the negative clock. So let's write it like this. Since there is a bubble in clock, okay, we consider negative clock. So negative clock comes. When the negative clock comes, okay, what should happen here? This 0 should move to Q3. This 0 now should move to Q3. See here? The 0 comes to Q3. Fine. And anyways, these zeros are there. So when this zero shifts, what is there here in the serial? It's just this. So that means whatever was there, what is the first bit that is there with J3? That is what this particular input, it's 0. So when the negative clock cycle comes, this 0 gets transferred to Q3. Why? What is the input now? When J3 is 0, K3 is 1. So when JK is 0, 1, output is 0, 1. So when input is 0, 1, output is 0. What is the input now? The first bit is 0. The first bit that should come in is 0. Understand? So when the first bit that has to come in is 0, J is 0. J of this flip-flop is 0. So if J of this flip-flop is 0, what is K of that flip-flop? It is 1. So when JK is 0, 1, what happens here? When JK is 0, 1, Q is 0, Q bar is 1. Q is 0, Q bar is 1. Yeah, this is the combination we are seeing. When JK is 0, 1, Q is 0, Q bar is 1. So that is what is happening here. So the first input is 0, that is J is 0. So K is 1 because of this NOT gate. So when J is 0, 1, Q3 and Q3 bar is 0, 1 respectively. So this 0 moves to this. So that means this 0 moves to Q3. Internally, I mean. So this is what is going to happen. Fine. Now, so that is what I need to write here. Okay. So this 0 comes to Q3. Now there is second negative clock cycle. What happens? Again, right shift 1, 0. This one comes here and this 0 comes here. Okay. All these will be shifted like this. There is another negative clock cycle. Fine. So again, it is shifted. So this 0 comes to Q3, 0, 1, 0. Okay. So this is what is happening. And this 0 comes here. Another negative clock cycle comes. This 1 becomes 0. They're all zeros. If they keep shifting means, okay. So this 1 comes here. So this 0 comes here. This 1 comes here. And this 0 again comes here. So 1, 0, 1, 0 sat here. Now again, we have to what? Go on giving this negative clock cycle. So when this negative clock cycle comes, again this gets shifted. So this 1 comes here, 0 comes here, and 1 comes here. That means 1, 0, 1. Serially, this 0 comes out. Fine. Another clock cycle. Fine. So this 1 comes here, this 0 comes here. So 1, 0 is the output. Another clock cycle. This 1 comes here, 0 comes out. So this is the output. So another clock cycle, this 1 also comes out. So it will be 1, 0, 1, 0. So this is how the bits are taken out. And for all these bits to come out serially, okay, how many clock cycles you need? 1, 2, 3, 4, 5, 6, 7, 8. 8 clock cycles you need to bring this data, which is here outside, to come here. For this serial data, okay, through these registers to come here, 1010, it needs after 8 clocks. That is possible, is what is written here. So everywhere it is shifting. First clock cycle J3 is 0, so Q3 is 0. Second clock cycle, this Q3 is given to J2, so J2 gives the data to Q2. In the third clock cycle, whatever was in Q2 gets shifted to J1. So this is how that shift happens, and finally you will have this. So this is right shift operation happening, and serial in, serial out is what is the fashion there.